Today we're going to start quadratic functions. Okay, so there's not just linear and nonlinear. There are different kinds of nonlinear. This is one of the main kinds of nonlinear that you'll deal with a lot, which is called quadratic. Okay, a quadratic function always has this shape, which we call a parabola. Okay, so when it's like a U shape, now it can be up and down. It can be facing downward, it can be to the left, it can be to the right, okay? But if it has that kind of U shape, then we call it a parabola. And all quadratic equations have that basic shape, okay? Now, sometimes they can open wider, sometimes they're narrower. You know, like I said, they can be pointing downwards or upwards or to the left or to the right, depending on what we do to the formula. But they're all going to have that basic shape, and they're all going to have this basic equation. Y equals ax squared plus bx plus c, where a can't be 0. In other words, there has to be an x squared term. Let's put that in simpler terms. So let's make up an example. Y equals, so a can be anything other than 0, so pick a number. Okay, we'll do 1. So 1x squared plus bx. Now, b can be any number including 0, so you don't necessarily have to have. In fact, a lot of the ones we're going to look at, in fact, I don't even know if we have any that have an x term in the textbook on here. I think most of them are just x squared, because that gets a little bit more complicated when you add the x term in there. So we'll say 0x plus c, which again can be any number including 0. So you can make 0. All right, so 1. So this equation would be x squared plus 1. Y equals x squared plus 1. Right? That would be one example of a quadratic equation. But I can change any of those values. The only thing that has to be true is that very first value has to be non-zero. The others can be 0, but it can be positive, it can be negative, it can be a whole number, it can be a fraction, it can be a decimal, anything but 0. Okay? So that's going to be the basic form of our quadratic equations, and their basic shape is going to be a parabola. So we're going to look at how to graph quadratic equations. And now, when you get further in, remember how I told you nonlinear get to be a pain in the rear? They will. But we're going to do it the simple way, which is we're going to simply use, what's this? A t-table, okay? We can use a t-table to graph quadratic functions just the same as we can use it to graph linear functions. So let's look at the example they have here. So here we're graphing y equals x squared minus 3. Is this in that form right there? Is it in quadratic form? Yeah, because it has y equals, this would be 1x squared, so it's a non-zero coefficient to the x squared. There's no just x, which means it has a coefficient of 0, right? 0x. And then minus 3, so our c value is negative 3, right? So it's in our quadratic form. And really, it's pretty easy. If it says y equals x squared anything or some number x squared, then it's going to be quadratic. As long as the biggest exponent you have is a squared in there, it should be a quadratic equation. So we've got that equation, and then you're just going to pick points. Now, one thing that's nice about what you guys are doing is, since we're not going to add those x terms in, yours are conveniently going to stay centered in the middle of the graph, which makes it easier when you're making a t-table. So good values to pick are always going to be 0, 1, 2, negative 1, and negative 2. Okay, because that'll get it centered around the middle of the graph. So that's what they did here. They used negative 2, plug that in. Now remember, a negative times a negative is positive. So we get negative 2 squared, which is 4, and 4 minus 3 is 1. So when x is negative 2, y is 1. Now the reason that it has this U shape though is because negative 2 squared is 4, but positive 2 squared is what? Also 4, right? Which means that positive 2 also has, if we have an equation that looks like this that doesn't have that x term in it, if it's just a quadratic, then this term right here is going to be the center of our graph, and it's going to be our y-intercept. It'll always be your y-intercept because, again, no matter what the equation is, let's say we take let's make up another quadratic equation just to see. All right, y equals, what's the number? Pick a number. Negative 1. Why are y'all obsessed with 1? Goodness. All right, negative 1x squared plus, pick another number. 5x. Pick another number.
4.
Plus 4. All right. So here's a quadratic equation. If I let x be 0, what happens to this term? A becomes 0, right? What happens to this term? A becomes 0, so we get y equals 4. So all of the x terms, when x is 0, all the x terms go to 0, so the constant term is your y. So just like with our linear equations, your constant is going to be your y-intercept every time. But as long as we don't have this term, it's also going to be the middle of our parabola. So that's kind of convenient because, again, you guys were looking at the simple versions this year. All right. So let's look at some examples together. Scroll this down. All right. So we're going to make a t-table for each of these. And again, since, notice all of ours we have no x term, right? No x term, no x term, no x term. They have an x squared term and a constant term. Guys, now this is important because, again, I want you to know that this is simple for this year, but I don't want you to go into next year and suddenly have ones that have x terms and then go, oh, but Miss Nichols said it was always centered around this. No. As long as there is no x term, which none of the ones that we're looking at this year have that middle x term, okay, for our purposes, our equation looks like y equals ax squared plus c. There is no bx in any of the ones we're looking at, okay? There's no just x term. If you throw that x term in there, it's going to change how it looks as far as where it is on the graph. But for our purposes, since this is what we have, it makes it a little easier. It tells us that we're always going to pick -2, -1, 0, 1, and 2. Those are always the values I want you to use because all of our graphs are going to be centered nicely in the middle of the graph because of the fact that there's no bx. There's nothing times x. There's just x squared and a constant. Okay? So because of that, we're going to use -2, -1, 0, 1, and 2 always. Now, let's look at this first equation. So our first equation is x squared plus 2. So -2 squared plus 2 is 6. It's not negative because a negative times a negative makes it positive, right? Next one, we have -1 squared plus 2. Then we have 0. Remember, your y-intercept, whatever your 0 is, that's going to be your y-intercept, so that one's easy. And then 1 squared is 1 plus 2 is 3, and 2 squared is 4 plus 2 is 6. And this is what we should see every time. If we put it -2, -1, -2 and +2 should have the same y. -1 and 1 should have the same y. So, and then that's our center point. Again, only true because of the fact that there's no x term. There's only x squared and a constant. Okay. But for the purposes of what you have to do this year, that's good enough. You'll know that those two should be the same. If they're not the same, then that means you made a goof on your math and you need to go back and fix one of them. All right? And then all you need to do is graph them. So we have -2, 6. And since this graph only goes up to 5, we're going to count by 2s to make it fit. So, -2 means I'm really going to go to the left just 1. And then up 6 means I'm going to go up 3. So that's my first point. Come on. Cooperate. All right. So there's -2, 6. -1 means we're going to go to the left half of 1. And up 3, so I'm going to go up 1 1/2. 0, 2 means I go simply up 1. So we have this point here. Sorry. This point here. This point here. Sorry, I'm not making it big enough. I have it zoomed in on my screen. Forget it doesn't zoom in as well there. All right. And then we have 1, 3. So again, 1, remember, is only half of 1 over since we're counting by 2. So I'm going to go half a unit over and up 3, which is really up 1 1/2. So I should have that one. Again, it should be a mirror image. You should have 1 on the left-hand side of the y-axis and 1 on the right-hand side, and they should reflect each other. And then we have 2, 6, so that's the right one, and up 3. So we have that. So that's what that looks like, right? And then you just sketch a parabola going through it. Remember, put arrows on both ends because it does extend infinitely upwards and outwards. Well, it doesn't circle, no. It's always going to go out a little bit more, just it's going to get to where it's increasing less and less. But it's going to continue going outwards. Yes?
Where did you get the middle one? The 0.
The 0, 2? That one? Left or right, none. Up 2, but remember we're counting by 2, so it's really up 1. -2, 6. Remember we're counting by 2, so that's left 1 and up 3.
Why didn't you make a mark over 1?
See? I did, right here.
How come you weren't getting there?
We're counting by 2s. So 2, 2, 4, 6. That's -2, 6. -1 means I go half over, and that's 2, 3 is halfway up. So that's -3. Does that make sense? Okay. All right. Let's look at one more together at least. All right. Let's look at the next one. What? Number 5. All right. All right. We'll look at number 5. All right. Okay. So we're going to look at number 5. Okay, so for this one, we've got -2 squared. So what's negative 2 squared? 4. And then I've got 1/4 of that. So what's a fourth of 4? 1, right? So that's 1. Which also means that one down there is going to be 1, right? Because negative 2 squared is 4, but positive 2 squared is also 4. So, well, make sure you double check your work, though, so you don't make a mistake. Because then you make the same mistake twice. All right. Negative 1 squared is 1. And 1/4 of 1 is 1/4, right? So that would also be the same for this one. And then 0 squared is 0 times the fourth is 0. So this is 0, 0. All right? So now, if I want to graph it, I know I've got 0, 0 on my graph. I have negative 2, 1. And here, since our units are really small, we could also count up by halves or even fourths. Like I could make each of the y values be a fourth. So if I did that, then going left 1 and up 1/4. Now this is labeling these by 1s and these by 4ths. And now you don't have to do that. If that confuses you, you can just do negative 1, 1/4, and just do a fourth of the way up. And positive 1, 1/4. And negative 2, 1. And positive 2, 1.
Oh, okay. I understand.
I don't know what.
Yeah. I understand.
All we're doing is graphing points, guys. Once you plugged in, all it is graphing points. You have an X and a Y. Huh?
I'm confused on how to find the numbers.
Yeah, you said go by 1/4, you said go by 2.
You're unsure how to do what?
Like, you just choose a random X, and then.
I told you negative 2, 1, negative 1, 0, 1, and 2. And guys, then it's a t-table. Remember t-tables that we did in the last? You just plug in the x value and find the y value. Well, you choose x, but I told you specifically which x's to use. Because since it's always going to be centered around 0, I told you use negative 2, negative 1, 0, 1, 2 as your x's. Guys. Now, this is just plugging in. And the fact that I have a lot of issues with it is probably shows why the tests were not so good on that unit. Guys, you should be able to plug into a basic t-table. It's just plug in an x value and solve for y. Look, x is negative 2, so 1/4 times negative 2 to the second power. Order of operations says exponents first, so negative 2 squared is 4. 1/4 of 4 is 1. So that's where that comes from. If you need to write it out on a scratch sheet of paper, that's fine, but it's just plugging in. Now, if I did the next one, negative 1, well, it's 1/4 of negative 1 squared. Again, order of operations says I do the exponents first. Negative 1 squared is 1. 1/4 of 1 is 1/4. So that's that y value. Then all you do is connect them into a parabola, and that's what that one looks like. Tell you what, for homework, I'll just have you finish 2, 3, 4, and 6. So do the rest of the ones on this for homework.
That is the rest.
Yeah.
Huh?
It's the whole paper.
I know I was going to assign you the skills practice. So this is notes. So yeah. Make, guys. So for each of these guys, make a T-table. Plug in your values, plot your points. If you label it by something other than counting by ones, which, like I showed you on that first one, we needed to just because it would have gone off the graph otherwise, then make sure and just make a note that, I counted by twos on X, or I counted by twos on both axes, or, Another thing to know is just because I'm counting by twos on the x-axis doesn't mean I have to count by twos on the y's. You can count by ones on the x-axis and by, halves on the y if you need to. So you want to make sure that it's a graph that you can see. So, you count by whatever means you need to.
On number 2, since it's negative x and